Hello students, let us discuss some of the important questions of the chapter pair of linear equations in two variables. So let us start with the first question. The question is, write the coordinates of the point such that line 3x plus 4y is equal to 12 meet x-axis. Write the coordinates of the point such that line 3x plus 4y is equal to 12 meet x-axis. Okay, so equation of the line is 3x plus 4y is equal to 12, and this line, when we draw the graph, meet x-axis at a given point, right? And we need to find the coordinates of that particular point. Clear? So here the important sentence, the important word is line meet at x-axis. When a line meet at x-axis, the coordinates of that point is x comma 0. Here the value of ordinate is 0 at x-axis. Clear? So if the ordinate is 0, so it means that if we put the value of y in this equation as 0, since this line meets x-axis, so the value of y is 0. Clear? Now putting the value of y as 0 in this equation, that is 3x plus 4 into y, that is 4 into 0 is equal to 12. So 3x is equal to 12 and x is equal to 4. So the value of x comes 4, right? So the coordinates of required point is 4 comma 0. 4 comma 0. Clear? Once again, write the coordinates of the point such that line 3x plus 4y plus 12 meets x-axis. On x-axis, the value of y is 0. After putting the value of y as 0 in this equation, 3x plus 4y is equal to 12. So this is 3x plus 4 into y, that is 4 into 0 is equal to 12. So 3x is equal to 12 and x is equal to 4. So the coordinates of the required point is 4 comma 0, right? So now come to the next question, number 2. The question number 2, okay. For what value of a, the system of linear equations 2x plus 3y is equal to 7 and a minus 1 bracket close into x plus a plus 1 bracket close into y is equal to 3a plus 1 represent parallel lines. Represent parallel lines. Okay, so we need to find the value of a. Clear? And we have two equations, 2x plus 3y is equal to 7 and a minus 1 bracket close into x plus a plus 1 into y bracket close is equal to 3a plus 1. And condition is represent parallel lines. Represent parallel line. Okay, so for parallel lines, the condition is a1 upon a2 is equal to b1 upon b2 is not equal to c1 upon c2. This is the condition for parallel lines, means no solution. Clear? So we have two equations, 2x plus 3y is equal to 7 and a minus 1 bracket close into x plus a plus 1 in bracket close into y is equal to 3a plus 1. Here the value of a1 is 2, right? Value of a2 is a minus 1, that is a minus 1. So a1 upon a2 is 2 upon a minus 1. Value of b1 is 3. So here b1 is 3 and the value of b2 is a plus 1. So this is a plus 1 is is not equal to C1 upon C2, right? So here the value of C1 is 7 and the value of C2 is 3a plus 1, right? So 2 upon a minus 1 is equal to 3 upon a plus 1 is not equal to 7 upon 3a plus 1. So taking first two equalities, here 2 upon a minus 1 is equal to 3 upon a plus 1. Now cross multiply, 2 into a plus 1 becomes 2a plus 2 and 3 into a minus 1 is 3a minus 3. Okay, so 2a minus 3a is equal to minus 3 minus 2. So minus a is equal to minus 5 and a is equal to 5. So the value of a is 5. Clear? For parallel lines, the condition is a1 upon a2 is equal to b1 upon b2 is not equal to c1 upon c2. This is the algebraical condition for parallel lines or for no solution. Clear? And after putting the values of a1, a2, b1, b2 and c1, c2 here, 2 upon a minus 1 is equal to 3 upon a plus 1. It's not equal to 7 upon 3a plus 1. So we take these two equalities. So 2 upon a minus 1 is equal to 3 upon a plus 1. And this is 2a plus 2 is equal to 3a minus 3. And finally we get the value of a as 5. So the value a comes 5. Right? Now come to third question. Look at this. The question number 3. Question number 3. Okay. If the system of equation 2x plus 3y is equal to 7 and 2ax plus a plus b into y is equal to 28, represent coincident lines. Represent coincident lines. Then find the relation between a and b. Then find the relation between a and b. Clear? Again, the question is, if the system of equation 2x plus 3y is equal to 7 and 2ax plus a plus b bracket close into y is equal to 28, represent coincident line. Represent coincident lines means infinite number of solutions. In that case, we need to find the relation between a and b. Clear? Okay. Now, for coincident lines or for infinite many solution, the algebraical condition is a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. So, a1 is 2, a2 is 2a, b1 is 3, b2 is a plus b, c1 is 7, c2 is 28. Okay. Now taking first two equalities here, look, after taking first two equalities, that is 2 upon 2a, it becomes 1 upon a. 1 upon a is equal to 3 upon a plus b. Clear? Now here 1 upon a is equal to 3 upon a plus b. Right? So cross multiply, a plus b is equal to 3a. So 2a is equal to b. So this is the first condition. Rather, this is the first relation between a and b. That is 2a is equal to b. Now taking second and third equality. Taking second and third equality. So that is 3 upon a plus b is equal to 1 upon 4. Cross multiply it and we get a plus b is equal to 12. A plus b is equal to 12. So we have two relations between a and b. First is 2a is equal to b and second is a plus b is equal to 12. 2a is equal to b and or a plus b is equal to 12. Once again, just go through. If the system of equation 2x plus 3y is equal to 7 and 2ax plus a plus b into y is equal to 28 represent coincident lines, then find the relation between a and b. Okay, so here coincident lines means infinite many solutions. For infinite many solution, we know The condition is a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. After putting the value of a1, a2, b1, b2, c1, c2 here, we look at 2 upon 2a is equal to 3 upon a plus b is equal to 7 upon 28 is equal to 7 upon 28. So this 2 gone. So 1 upon a is equal to 3 upon a plus b is equal to, this is 1 4, 1 upon 4. So 1 upon a is equal to 3 upon a plus b is equal to 1 upon 4. Now taking first two equalities, that is 1 upon a is equal to 3 upon a plus b. So 3a is equal to a plus b, and finally 2a is equal to b. Now these two, 3 upon a plus b is equal to 1 upon 4. So cross multiply, that is a plus b is equal to 12, and we have two relations. One is 2a is equal to b, or a plus b is equal to 2, right? Okay, come to question number 4, and okay, this is question number 4, and the question is the system of linear equation 2x plus 3y minus 9 is equal to 0 and 4x plus 6y minus a2 is equal to 0 consistent? Justify your answer. We need to find whether the system of linear equations 2x plus 3y minus 9 is equal to 0 and 4x plus 6y minus 18 is equal to 0 consistent or not. Okay, to know this, we need to find the value of a1 upon a2, b1 upon b2, c1 upon c2, right? So look at here, a1 upon a2, that is 2 upon 4. So 2 upon 4, simplest form is 1 upon 2, correct? b1 upon b2 here, that is 3, and this is 6. So 3 by 6, ultimately this is 1 by 2, clear? c1 upon c2, we have minus 9, minus 18 here. So minus 9 upon minus 18 becomes 1 upon 2. So we see that the value of a1 upon a2, 1 by 2. The value of b1 upon b2, 1 by 2. Value of c1 upon c2, 1 by 2. So a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2 is equal to 1 by 2. Look, right? So this is the condition, and due to this condition we know that infinite many solutions are possible. Clear? When a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2, then infinite many solutions are there. If infinite many solutions are there, then the system of linear equation is consistent. Then the system of linear equation is consistent. Clear? When we have infinite many solution, then we say that system of linear equation is consistent. Clear? So to know whether the system of linear equation is consistent or not, we need to find the values of a1 upon a2, b1 upon b2 and c1 upon c2. Then find the relation. Here in this specific question, we are getting that a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2 is equal to 1 by 2, right? Okay. So in this case, infinite many solutions. That is why the system is consistent. So we are doing each and every type of question in this video, right? For which value of k will the following pair of linear equations have no solution? Now no solution. Okay, value of k needs to find. So equations are 3x plus y is equal to 1, and this is 2k minus 1 bracket close into x plus k minus 1 bracket close into y is equal to 2k plus 1. So we have two equations in front of you, that is 3x plus y is equal to 1, and this is the second equation, 2k minus 1 bracket close into x plus k minus 1 bracket close into y is equal to 2k plus 1, right? Now we know that for no solution, the condition is a1 upon a2 is equal to b1 upon b2 is not equal to c1 upon c2. This is the condition for no solution, right? Now needs to put the values of a1, a2, b1, b2 and c1, c2 here. So look at here, the value of a1 is 3, so we write 3. The value of b1 is 2k minus 1, value of a2 is 2k minus 1, and the value of b1 is 1, right? And the value of b2 is k minus 1, and c1 is 1, and c2 is 2k plus 1 here, 2k plus 1, because this is negative sign, negative negative plus, ultimately here cancel, right? So now taking first two equalities, when you take first two equalities, already 3 upon 2k minus 1 is equal to 1 upon k minus 1. Cross multiply it, 3 multiply by this k minus 1, so 3 into k minus 1, and this 2k into 1, 2k plus 1 in 2k minus 1 into 1 is equal to 2k minus 1. So the value of k comes 2. 3k minus 3 is equal to 2k minus 1, then 3k minus 2k here, and minus 3 that side, minus 1 plus 3, so k is equal to 2. So the value of k comes 2. Here you can check with the second equalities also, that is 2k plus 1 is not equal to k minus 1, and here we are getting k is not equal to minus 2. K is not equal to minus 2, right? So the value of k is 2, and it should not equal to minus 2. So that is the answer. The value of k is equal to 2. The given pair of linear equation have no solution when we take the value of k as 2, right? Simple. For no solution, the condition is this: a1 upon a2 is equal to b1 upon b2 is not equal to c1 upon c2. Then after putting the values, taking first two equalities, clear, and then cross multiply, and we get the value of as k as 2. Then take this one, k should not equal to minus 2, and finally we see that k is equal to 2, right? And now come to question number 6. Question number 6. Just wait. Fine. Okay. For which values of p and q will the following system of linear equations have infinite many solutions? Have infinite many solutions. Okay, so we have two equations, 4x plus 5y is equal to 2, clear? And the second equation is 2p plus 7q bracket close into x plus bracket start p plus 8q bracket close into y is equal to 2q minus p plus 1. So in front of us we have two equations, and for infinite many solutions, the condition is a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. This is for infinite many solution. Clear? Now from these two equations, we write the value of a1, that is 4, the coefficient of x of the first equation. a2 is 2p plus 7q, the coefficient of x of the second equation. b1 is 5, coefficient of y of the first equation, so this is 5, and coefficient of y of the second equation is b2, that is p plus 8q, and then you have your c1, that is 2, and c2 is 2q minus p plus 1. Clear? So 4 upon 2p plus 7q is equal to 5 upon p plus 8q is equal to 2 upon 2q minus p plus 1, right? Now taking first two equalities here, these two, so 4 upon 2p plus 7q is equal to 5 upon pq plus 8. Now cross multiply. Clear? 4 into p plus q, 4 into p plus 8q is equal to 5 into 2p plus 7q. So it becomes 4p plus 32q is equal to 5 2s are 10, that is 10p is equal to 5 7s are 35, that is 35q, right? And finally we get the value of q in terms of p, that is q is equal to minus 2p. Q is equal to minus 2p. So this is the relation after solving first two equalities, right? Now look at second and third equalities, that is 5 upon p plus 8q is equal to 2 upon 2q minus p plus 1. So after cross multiplication we get 5 into 2q minus p plus 1 is equal to 2 into p plus 8q, right? 8q plus 1. Okay. 8q plus 1. Wait. Okay. That is 5 into 2q minus 1 minus p plus 1 is equal to 2 into p plus 8q. Now 5 2s are 10q minus 5p, 5 1s are 5 here, and 2 into p is 2p, and 2 into 8q is 16q. So here minus 5p plus minus 2p is equal to 6q minus 10q minus 5, and we have a relation here, minus 7p is equal to 6q minus 5. Okay, now from this equation 1, putting the value of q as minus 2p here, this is 6q, so minus 7p is equal to 6 into q. The value of q is minus 2p, so here we put the value of q as minus 2p, so 6 into minus 2p minus 5, and minus 7p is equal to minus 12p minus 5, and finally we get minus 7p plus 12p is equal to minus 5, so p is equal to minus 1. 5p is equal to minus 5, so p is equal to minus 1. Now putting this value of p as minus 1 in equation 1, we get q is equal to minus 2 into minus 1, that is q is equal to 2, right? So in this case, in this question, the value of p is minus 1 and the value of q is 2. The value of q is 2. The value of q is 2, right? And now come to question number 7. Come to question number 7. Again, for what values of p the following pair of linear equations represent parallel lines? Again, 2x plus 3y is equal to 8. Second equation is bracket start p minus 1 bracket close into x bracket start p plus 1 bracket close into y is equal to 3p minus 1. Clear? Now for parallel lines, it means for no solution the condition is a1 upon a2 is equal to b1 upon b2 is not equal to c1 upon c2. This is the condition for no solution. This is the condition for parallel lines, right? Now from these two equations, put the values of a1 a2 b1 b2 and c1 c2 here in this condition. So we get 2 upon p minus 1 is equal to 3 upon p plus 1 is equal to 8 upon 3p minus 1. Okay, so 2 upon p minus 1 upon p plus 1 is not equal to 8 upon 3p minus 1. Now after taking first two equalities, the first two equalities, that is 2 upon p minus 1 is equal to 3 upon p plus 1. So after cross multiplication we get 2 into p plus 1 is equal to 3 into p minus 1. So 2p plus 2 is equal to 3p minus 3. So p is equal to 5. Okay, after solving this we get p is equal to 5. So the value of p is 5, right? Question is clear, right? For parallel lines, this is the condition. a1 upon a2 is equal to b1 upon b2 is not equal to c1 upon c2. Put the values, that is 2 upon p minus 1 is equal to 3 upon p plus 1 is not equal to 8 upon 3p minus 1. So 2 upon p minus 1 is equal to 3 upon p plus 1. So cross multiply, 2 into p plus 1 is equal to 3 into p minus 1, and finally we get the value of P as 5. So the value of P is 5. Clear? Now come to question number 8. Okay, the question number 8 here. Just wait. Okay. Find the values of m and n for which the system of equations 3x minus bracket start 3m plus 4 bracket close into y is equal to 8 and bracket start 2n plus 1 bracket close into x minus 5y is equal to 16 has infinite many solutions. Clear? So we have two equations. This is first and this is equation number 2, right? And the condition is infinite many solution. For infinite many solutions we have a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. So this is the condition for infinite solution. This is the condition for coincident lines. Clear? So after putting the values of a1 and a2, so this is 3 upon 2n plus 1, 3 2n plus 1, and b1 is minus bracket star 3m plus 4. Okay, and here b2 is minus 5, so we write minus 5, minus with minus gone, is equal to c1 upon c2, that is 8 upon 16, that is 8 upon 16 is 1 upon 2. Clear? So taking first two equalities here, that is 3 upon 2n plus 1 is equal to 1 by 2, cross multiply 2n plus 1 is equal to 6, so n is equal to 5 by 2. The value of n comes 5 by 2. And now after taking last two equalities, that is 3m plus 4 divided by 5 is equal to 1 upon 2. Now 6m plus 8 is equal to 5, cross multiply. Okay, 2 into 3m 6m, 2 into 4 8, 5 into 1 5, so 6m plus 8 is equal to 5. Now the value of m, that is 6m, is equal to minus 3 and m is equal to minus 3 by 6, and the value of m is minus 1 by 2. The value of m is minus 1 by 2. So m minus 1 by 2 and 5 by 2. Clear? Now come to question number 9. So today's question number 9. Okay, fine. Find the value of k for which the system of equation 2x plus k minus 2 bracket close into y is equal to k. This is k. And second is 6x bracket start 2k minus 1 bracket close into y is equal to 2k plus 5. Represent coincident lines. Clear? So here for coincident lines, it means for infinitely many solutions. For infinitely many solution, we know the condition, that is a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. So here a1 is 6, right? Rather a1 is 2 and the a2 is 6. So k minus 2 is your b1 and 2k minus 1 is your b2, and k is c1 and 2k plus 5 is c2, right? So value of a1 is 2, and value of a2 is 6, value of b1 is k minus 2, value of b2 is 2k minus 1, and value of c1 is k, and the value of c2 is 2k plus 1. So taking first two equalities here, 2 upon 6 is equal to k minus 2 upon 2k minus 1. By cross multiplication we get 2 into 2k minus 1 is equal to 6 into k minus 2, right? So 4k minus 2 is equal to 6k minus 12, and this 4k minus 6k, and this is minus 12 plus 2 here, and finally the value of a is 5. When you solve, we get the value of k as 5, right? Taking last two equalities, that is k minus 2 upon 2k plus 1 is equal to k upon 2k plus 5. Now cross multiply it. When you cross multiply, we get k minus 2 into 2k plus 5 is equal to k into 2k minus 1. So here, this is 2k square plus 5k minus 4k minus 10 when you multiply these two terms, and then when you multiply k with 2k minus 1, we get 2k square minus k, and finally the value of k comes 5. So here also, after taking last two equalities, we are getting the value of k as 5, and here also we are getting the value of k as 5. Okay, so finally the value of k is 5. Finally the value of k is 5. Now come to question number 10 and the first part. Question number 10 and the first part. Okay, the question number 10, the first part is solve the following pairs of linear equations. First, x plus 1 by 2 minus y plus 4 by 11 is equal to 2. And the second equation is x plus 3 by 2 plus 2y plus 3 by 17 is equal to 5. Clear? Once again, this is first equation. X plus 1 by 2 minus y plus 4 by 11 is equal to 2, and the second equation is x plus 3 upon 2 plus 2y plus 3 upon 17 is equal to 5. Clear? Now what you have to do, we have to take the LCM. Okay, there is no other option. Here x plus 1, here x plus 3, here x plus 4, here x plus 2y, here y plus 4, here 2y plus 3. So we have only one option to take the LCM. LCM is 22, so it becomes 11 into x plus 1. This is minus 2 into y plus 4, and in this equations, that is, you take the LCM as 34. 17 into x plus 3 plus 2, 2y plus 3 is equal to 5. Right? Now cross multiply it. Clear? So finally we get 11x plus 11 minus 2y minus 8 upon 22 is equal to 2, and 17x plus 51 plus 4y plus 6 upon 34 is equal to 5. Now by cross multiply. Clear? So we get 11x minus 2y plus 3. This is 11 minus 8 is 3. So 11x minus 2y plus 3 is equal to 44, and finally the equation 1 is 11x minus 2y is equal to 41. So we have with us equation 1 as 11x minus 2y is equal to 41. Now look at here. After taking LCM, the numerator becomes 17x plus 51y plus 4y plus 6 upon 34 is equal to 5. Solve further. 17x plus 4y and 51 plus 6 is 57 upon 34 is 5. And finally, the second equation in front of us is 17x plus 4y is equal to 113. First equation is this, 11x minus 2y is equal to 41. Second is 17x plus 4y is equal to 113. Now what to do? Now if you multiply this equation by 2, so this becomes minus 4, right? And here we have plus 4. After multiplying equation 1 with 2, we get 22x minus 4y is equal to 82, right? So this is equation number 3, and this is equation number 2. On adding equation 2 and 3, so 17x plus 4y is equal to 113, and 22x minus 4y is equal to 82. Finally we get the value of x as 195 upon 39, that is x is equal to 5. And after putting the value of x in equation 1, we get 11 into 5 minus 2y is equal to 41, and minus 2y is equal to minus 14, so y is equal to 7. So we have two values, that is x is equal to 5 and y is equal to 7. X is equal to 5 and y is equal to 7. Now come to the second part, and second part is again simple. Here 133x plus 87y is equal to 353, and 87x plus 130y is equal to 307. Look at in this question, the coefficient of x of the first is same as the coefficient of y of the second, and the coefficient of y of the first is same as the coefficient of x of the second. In these type of equations, one time you have to adding 1 and 2, so we get finally, if you add 1 and 2 here, right, 220 into x plus y is equal to 660, and finally a one equation comes, that is x plus y is equal to 3 after adding equation 1 and 2. When you add equation 1 and 2, we get x plus y is equal to 3. Now subtracting one from another, here we are subtracting equation 1 from equation 2, and we get minus 46 into x minus y is equal to minus 46, and it is x minus y is equal to 1, that is equation number 4. Now on adding equation 3 and 4, we get the value of x as 2, and after putting the value of x in equation 4, we get the value of y as 1. The value of y as 1. So the value of x is 2, the value of y as 1. Okay, so in these type of equations where the coefficient of x of the first is equal to the coefficient of y of the second, and coefficient of y of the first is same as the coefficient of x of the second. Remember, one time we have to add and then get the equation, that is x plus y is equal to 3, and next you have to subtract one equation from another, and we get x minus y is equal to 1. So we have two equation 3 and 4. After adding these two, value of x comes 2, and after putting the value of x in equation 1, we get the value of y as 1. So y1 x2. Now come to third part of question number 10. So this is a plus b bracket close into x is equal to a minus b bracket close into y is equal to a square plus b square, and a minus b bracket close into y is equal to a plus b into y is equal to a square plus b square, a square plus b square, right? So look at here, we are going to solve this question with the elimination method, where we have to make the coefficient equal. So here we on multiplying equation 1 by a minus b, by doing so we are making the coefficient of x as a square minus b square, and after multiplying equation 2 with a plus b, again making the coefficient of x as a square minus b square. So on multiplying equation 1 by a minus b and equation 2 by a plus 1, equation 2 by a plus 1, right? So finally we get these two equations. The first is a square minus b square into x plus a square plus b square minus 2ab into y is equal to a cube plus ab square minus a square b minus b cube, right? Look, when you multiply this with plus b here, so a minus b into a plus b is a square minus b square, and a minus b into a minus b is a minus b whole square. A minus b into a minus b is a minus b whole square, and a square plus b square minus 2ab, you can write a minus b whole square as this. And when you multiply a minus b into a square plus b square, okay, we get a cube plus ab square minus a square b minus b cube. So this is equation number 3, right? And when you multiply equation 2 by a plus b here, so coefficient of x becomes a square minus b square. This is a plus b into a plus b becomes a plus b whole square. So this is a square plus b square plus 2ab into y, and when you multiply a plus b into a square plus b square, we get a cube plus ab square plus a square b plus b cube, right? So we have two equation 3 and 4. Now on subtracting equation 3 from equation 4, okay, so this is gone. Here you can take y common. When you take y common, so inside this, look, when you take y common from here, we get a square plus b square plus 2ab, right? Minus a square minus b square plus 2ab, needs to change the sign, right? And here this is gone, and finally we get 2a square b plus 2b cube. Clear? So here on the left hand side, we get 4ab into y is equal to 2b into a square plus b square, right? So the value of y is 2b into a square plus b square upon 4ab, and finally the value of y is a square plus b square upon 2a, a square plus b square upon 2a. Now on putting the value of y in equation 1, after putting the value of y in equation 1, look at here, this is a minus b, this is y, so this is a square plus b square upon 2a, the value of y. And after solving this, you have to do little bit of calculation, and then we get the value of x as a square plus b square upon 2a. So the value of x, a square plus b square upon 2a, and the value of y as a square plus b square upon 2a. So look at here, the value of x, a square plus b square upon 2a, and the value of y as a square plus b square upon 2a. Clear? Now come to fourth part of question number 10. Okay, fourth part of question number 10. Question is ax plus by is equal to 1 and bx plus ay is equal to a plus b whole square upon a square plus b square minus 1. Right? Again, first equation, ax plus by is equal to 1. Second equation, bx plus ay is equal to, after taking the LCM as a square plus b square, we get the numerator as a square plus b square plus 2ab minus a square minus b square, and finally the equation 2 is bx plus ay is equal to 2ab upon a square plus b square. Right? Now on multiplying equation 1 by b, if you multiply this equation by b, we get abx plus b square y is equal to b. Okay, and on multiplying equation 2 by a, we get abx plus a square y is 2a square b upon a square plus b square upon a square plus b square. So we have two equations. Okay, first equation is, rather third equation here is abx plus b square y is equal to b, and the fourth equation is abx plus a square y is equal to 2a square b upon a square plus b square. Here the coefficient of x is same, that is ab. Right? So on subtracting equation number 3 from equation number 4, on subtracting equation 3 from 4, so we had abx plus a square y is equal to 2a square b upon a square plus b square. Right? So this is abx. Now since we are subtracting, so needs to change the sign. This is minus, this is minus, this is minus, and this is gone. Here you can take y common. If you take y common, we left with a square minus b square, and this is 2a square b upon a square plus b square minus b on the LHS. And on the LHS you have to take the LCM. Here the LCM is a square plus b square. After taking LCM, a square plus b square, the numerator becomes 2a square b minus a square b minus b cube when you take the LCM here. Right? And when you solve on the right hand side, it becomes a square b minus b cube, and in the denominator we have a square plus b square. In the denominator we have a square plus b square, and finally the value of b comes b upon, the value of y, sorry, the value of y is b upon a square plus b square. Right? This is gone, so y is equal to b upon a square plus b square. After putting the value of y as b upon a square plus b square in equation 1, right? So ax plus b into y, that is b upon a square plus b square is equal to 1, and it becomes ax plus b square upon a square plus b square is equal to 1. Now take this to the right hand side here, and then take the LCM as a square plus b square. Finally we get the value of a. Here this is a square upon a square plus b square, and ax is equal to a square upon a square plus b square. So this is gone with this a, and finally the value of x is a upon a square plus b square. So here in this question the value of b is, the value of y is b upon a square plus b square, and the value of x is a upon a square plus b square. Clear? Now come to fifth part of question number 10. Fifth part of question number 10. Again a good question. All the questions are good. Important questions and stuff. Okay. Question number 10, fifth part. 3 upon 3x minus y plus 2 upon 3x plus y is equal to 2, and second equation is 10 upon 3x minus y plus 2 upon 3x plus y is equal to 11 by 2. Look at here, this is 3x minus y, here 3x minus y, here 3x plus y, here 3x plus y, right? So in these type of questions, we have to suppose we have to let 1 upon 3x minus y is equal to a, and 1 upon 3x plus y is equal to b. 1 upon 3x minus y is equal to a, and 1 upon 3x plus y is equal to b, right? So equation 1 becomes, that is here, final equation 1 is 3a plus 2b is equal to 2, and 10a plus 2b is equal to 11 by 2, right? Now we have to solve these two equations. Now we have to multiply equation 1 by on subtracting. Now look at here, the coefficient of b is 2 here and the coefficient of b is 2 here. So on subtracting equation 1 from equation 2, here 10a plus 2b is equal to 11 by 2, and this is 3a plus 2b is equal to 5. So here we have 7a is equal to 11 minus 4 by 2, and a is equal to 1 by 2. The value of a comes 1 by 2. Now after putting the value of a as 1 by 2 in one of the equation, we get 3 into 1 by 2 plus 2b is equal to 2, and 2b is equal to 1 by 2, and b is equal to 1 by 4. So a is 1 by 2 and b is 1 by 4, right? So a is 1 upon 3x minus y. So here, since a is equal to 1 by 2, so 1 upon 3x minus y is equal to 1 by 2, and finally 3x minus y is equal to 2. This is equation number 3, and here the value of b is 1 upon 4, but b is equal to 1 upon 3x plus y in the beginning. So here cross multiply, and then we get the fourth equation as 3x plus y is equal to 4, and here 3x minus y is equal to 2, right? Now we need to solve these two equations by adding these two, this y gone, right? So 3x plus 3x, 6x is equal to 6. So ultimately x is equal to 1. Okay, now after putting the value of x as 1 in equation 4 here, right, it becomes 3 into 1 plus y is equal to 4, and 3 plus y is equal to 4, and y is equal to 1. So we have the value of x as 1 and the value of y as 1. Okay, the question is simple, but what is the important concept here? The important concept is, in this question, you need to see, this is in the denominator, that is 3x minus y. Here is again 3x minus y. Here in the denominator 3x plus y. Here in the denominator 3x plus y. So it's easy for we people to take a is equal to 1 upon 3x minus y, and b is equal to 1 upon 3x plus y. After putting the value, you get two equations, then solve these two equations in terms of a and b, and then after solving and getting the value of a and b, convert into again in the form of x and y, and then again solve these two equations for x and y here by adding these two equations here. You get the value of x as 1 and the value of y as 1. Okay, right? So students, this was the first part of some of the important questions of pair of linear equation in two variables. Okay, in the next part we'll be discussing some of the more few important questions of linear equation of two variable in part 2. Okay, so thank you very much.